The first topic is going to be monorepos versus what's the other side of monorepo? Right? Multi-repo. Yes. If you notice in like the things that we sent out, it's like every time I switched it, it's like multi-repo, well, something else. Like I don't know what the other side of the story is. So, Christine, I think you asked for this topic. You suggested this topic.
Yeah.
You want to kick us off?
Yeah. The impetus for this was arguments, or rather discussions, in my own group over how we want to manage repositories for a project I'm on, because we're going to clean them up. They're a total mess at the moment, a nightmare, and so we want to clean them up and get them into a sensible sort of structure. And then there was an argument over how many repositories we should have. Should we have more than one? Because in another project we have like 7 or 8 repositories, and we end up tagging all of them at the same time, deploying them all at the same time, and treating them like one repository anyway, because they're all so interconnected. So I was like, if we're going to treat them all like one repository anyway, let's just have one repository. And then we went back and forth. So I'm sure that this discussion is going to be equally useful, but I wanted to get some other people's viewpoints on this, and like particularly like if you have multiple repositories, how do you manage the dependencies between repositories and versioning and all of that? And if anybody wants to like say within a repository, this is how I love to structure stuff. That was also fun. So there you have it.
Any thoughts on that?
So I can share with everyone what Matt Thompson and I did with our summit last year. So the organization we work with, the GMAO, had been using CDS very successfully for about 20 years, but with all the downsides of this, but they were heavily dependent upon CDS modules, which there's no good getting. So we have been pushing for Git for a while, and finally we got sort of the go-ahead this summer to do it. The problem we had as we're going from CDS to Git, aside from just the technology differences, is that we also have ability to share repositories across agencies. So like our dynamical core is actually a NOAA model, and NOAA now wants to use our aerosol component. And so there became some good rationale to take this, what had been a large monolithic repository that had very complicated people process commits and splitting it out. So then we had a more fine grained. Well, there's other issues there, but I'll try to stick to the things that are most relevant to us. To some degree, this has worked very well. So we probably are now up to about 20 repositories that we have, and tagging, yeah, has some issues, but it's more commits are a problem, right? Oftentimes changes in 2 repositories have to sort of go in at the same time, but it's 2 separate pull requests, but they have to be approved in the right order. The technology we're using to manage all this is something called manage externals, which comes out of NCAR. And it only addresses a narrow part of the problem, but at the time it seemed enough to us. What it lets us do is we check out the top repository. It has a config file in it. They have a Python thing called manage externals, which will then check out all of the other repositories, place them with appropriate tags or branches, place them in the appropriate subdirectories, and can give us a status across the whole thing. It doesn't let us do, branch across all of them, tag across all of them, commit across all of them, pull request across all of them. And CI is an ongoing challenge because most of these repositories can't build on their own. So anyway, I'm happy to ask some more questions, but it's been a mitigated mess.
So the way you guys are going is the multi-repo. That's what it sounds like. And then, so I guess on the flip side of that, I didn't think about it beforehand, but I guess we have a monorepo for a lot of the projects we're in. So we have, let me take that back. We have probably 100 different repos, right? But they're all separate projects, right? They're independent, separate projects. But we have, in terms of like some of the larger projects that we have, I didn't think about them before this thing. They're all monorepos. They have probably like multiple, like there's multiple. I think one of mine there's 20 different different libraries or components or whatever. They're all separate projects, but they're all in one repo. I think, just my opinion, if the multiple repos are going to change together, then they're not independently deployable, then they should be in the repo with the thing that they're changing with, or the thing that's deploying that they need to deploy. Well, I strike that last statement, because you can have it as a dependency, like then you end up packaging it up and then putting that package in. But if they're going to change lockstep together, then in my opinion, they should probably be in the same repo together.
the difficulty we run into is that there are certain things that we do over and over and over again. And we really, there are some like little pieces in libraries that actually share in between like feeling the time, I hate time, feeling the time, something to do all the time. And like the commercial libraries out there are fabulous, but there's certain specific things we do within that, so we run into this tension of like, well, there's one Python library, there's one Perl library, there's one thing might actually be useful somewhere else. But, in general, if we make that a separate project, then we kind of are on board with the idea of like having to notify other people who are using it if we make changes. It's sort of, but I agree with you, especially like if you're going to deploy, if they're so entwined, like if you're always deploying them together.
It sounds like you still have one advantage over us with separating. Our biggest problem is when we get to the science layers. The infrastructure layers sort of look like what you're describing. We have our homegrown infrastructure that evolves by zone semantic versioning, and we bring in other people's infrastructure and they evolve. But but then it's just a matter of updating the config when we want to use a new version. That's not the problem. It's when we get to the science layers and like the chemistry component needs a change that goes along with it, the physics component, and they go together because neither of them has sort of independent acceptance criteria. The acceptance criteria is that it doesn't break the model. Or in the best case, it improves the model. But the good ones are when it's just a new feature that's not turned on by the model. And then the worst part is the time lag. So we can, to do the testing necessary for this takes a human being a few hours. We think once we get CI set up right, we get that down to, maybe an hour or so. But that's just the preliminary. At some point, somebody down the line is going to use our data assimilation system, and they're going to find out that we lowered our forecast. So I think, and we have to go out and figure. So that's unavoidable. That one's bad. So if you have independent criteria for why each one of these pieces can be upgraded to its next version, and it's he's tested on its own, that probably will, as long as you have a good tool then for managing which versions go into which project, you're probably okay.
So that goes to a topic that we did a little while ago. Like, because one of the things that we found is that we have to separate how's the right word, deployment from turning the feature on, right? So in your case, say these two independent things can be deployed independently, but the feature can't be turned on until both are there, right? So if you have a feature flag, something saying, hey, I deployed this, but this other part's not ready, therefore the flag is turned off. And then when everything's there, then someone else independently says, I am now deploying, what's the right word? Delivery? I can't remember the terms. I have to go back and look at the talk, but separating like shipping the code from turning the feature on. Right? So now they can ship independently, but the feature can be turned on when everything is there, right? But that means you have to have kind of infrastructure for both on and off being there at the same time. Like it requires more thought in your deployment process. You can't just like take the if state, take this part, comment it out or delete it and put the new stuff in. You got to have both in there.
Ours is done with configuration files and shipped to the system, so we always have a default value. If somebody wants that on, we're not quite in an operation mode like you are. They go in and they edit that line. And so the scientist that's researching that next version turns it on for them work. No one else is afflicted with that.
I was going to ask, are each of the science groups, the others, do they have their own repos, or are you guys?
So again, before this, except for some purely external lower level libraries, it was all one monolithic CDS. It's mostly code built here at NASA. We have external science collaboration stuff, so some code contributed outside. So what we've done now is we've created a new org on GitHub that is us, called CSM or something like this. And under that umbrella, we have, Matt, how many we have now? Over 20, I think.
28. That was going to be my follow-up question: is how many people are actually using outside the GitHubs or the developer.gsfc where you pay the $100?
We were going to do that until that.
Yeah. We're using internal tools. Our plan was, again, originally to do developer.nasa.gov for everything, but paying $100 and whatever it is versus the $3 we pay per user per month. I'm like, yeah, we'll stick with that. And it's a half, well, it's not, I guess, totally about it.
How much of a hassle is it to let everything I've done here for almost 25 years has always been internal? It's never been allowed.
external. But I think, so I guess part of my question, and maybe it's part of your question too, is are you, it's not like you're building everything from source. Like, are you guys, do you, like, I think if you have a multi-repo sort of situation, you have to kind of end up packaging those other repos and then you would consume the package, not necessarily the raw code.
Yes, do people have like their own packaging managers for like internal packages? Like your own NPM repo,
So,
your own.
That's where you were looking into some of that too, weren't you?
I couldn't hear her very clearly. What did she say?
The question was internal package managers. Do they exist? I kind of know the answer. But I know.
Internal package managers in terms of like pulling your own packages. You can, one strategy I've employed in the past is using npm because it accepts, instead of a semver expression in a package reference, you can say I want it from this git URL and then hash like this branch or this tag or whatever. So that way, at least in the node world, you can just sort of handle your multi-repos that way. I think there are some packages, I don't know if pip has that, but I've seen a number of different ways to handle it depending on environment.
Yeah. A lot of package managers will have an on-premise kind of proxy that you can go through. And I know Adrian, I can never remember which one.
Andrew.
Yeah.
Yeah. I was just talking to him today about this. So they have a internal pip, npm, and Docker repository. And I think that's supposed to be free once it fully rolls out. Right now, I think you have to put a NAMS request in, so I would recommend talking to him. But I think that's just supposed to be an agency-provided service.
Yeah. So that gives you a place where you can put your packages internal to NASA, and then pass through for your packages that are not internal. So if you have a package there, you can pull it. If there's not a package there, then apparently it goes through to the other official package manager tool for that.
Right, but in this case, right, so I think that one, what it was trying to address was like blessed packages.
Mm-hmm.
But like we have a Docker image repository, which is for images that are internal to us, but that we want access to.
Mm-hmm. Yeah, that's the not public part is the part I'm not sure about. I mean, I'm guessing you can just still put them there, but then other people may be seeing them. I'm not sure.
Right, so other people, like for example, other people in our organization can see them internally.
Yeah. So internal means different, like, so internal to the.
Not internal to NASA, internal to the
Yeah.
organization.
And that's the part I'm not sure about. I know the other part is internal to NASA, but maybe you have packages that you only want your team to be able to see, that sort of thing. I'm not sure. I do know it's something, maybe if you reach out to Andrew and say, hey, there's a need, maybe they can build that into their solution that they're building.
It's not necessarily hard to set these, horribly hard to set these things up yourself. It's just like, right? Because I mean, like as soon as you have Python, you have all kinds of your requirements.txt or pip file or however you call your conda, whatever, right? And then it's sort of equivalent to the configuration file that packages. You can just add other repositories and components. We haven't got that sophisticated complex or anything other than Docker.
Keep going. I'm going to see if I can make the audio a little bit better from those on mine.
So if you want to again, would you continue to explain this, or would you?
Well, again, some of it's sort of just necessary for the collaboration. I think we would have maybe delayed that part of the rollout. It was one of those things where it sort of snowballed. Mandy was good at it. I was going to go from make to CMake as part of that. And that part worked pretty well. We couldn't get the needs for the two workflow under CVS and then issue tags and other
Turn on
individual files. That doesn't work friendly at all. So I, after getting frustrated, even trying to get them to explain their process, I eventually said, look, let's split the GCM into one, sorry, the model into one, and the data solution into one. And then we got the mandate from NOAA to share our chemistry. And there's all along been this notion that all this code if we did this, and then we go to the people, there's good ideas about why you want something to be very thin repositories at the top, and sort of say what repositories they use. So you have like a lot of other. So
Right.
it's sort of snowballed that way. Then what do you? But then we got our shared layer. Where do we put that? Okay, all of our shared layers. Oh, but there's one that has a really fast uptick. So it snowballs that way. So that's why we're up to about 20. It's not going to grow more. Would I do it again? Yes, but we need a better tool. We need a tool that doesn't just check this stuff out and tell us what to change. We need one that lets us do the rest of it. We want something that makes it look like we're doing a single Git repository. We're using something called Manage Externals. We're looking very closely at something called Git A or developer that sort of does exactly what we want. But there's other ones out there. So there's a out of ECMWF, there's something called PC Build that does this through CMake. Theirs is really nice in the sense that if two different components, that the CMake itself is managing each version, right? So if a top level component's already installed this library, when it gets down to this other one, it's not going to reinstall it, but it will check to make sure that the requirements of the version system. So that's sort of nice. What theirs won't do is nest in the directory tree where things are. All of our users are insisting, oh no, we're used to seeing chemistry under physics. We've got to put chemistry under physics. Chemistry is now set. Do that day one. Someday needing to do that. So there's options, but none of them seem to quite get all of our.
Yeah, we're just starting, and we're using the Drupal.
We looked at that, but since it was only on the Android, we were a little bit very. Otherwise, seems
well,
somewhat.
Yeah, they're using it for Android, but we're trying to use it in our products. It's still a work in progress, but it's kind of interesting. I don't think it does what you just said as far as being able to not install something from install. It's basically just it's a manager of multiple repositories, and you have one XML-based manifest file that specifies all the repositories you want and version. Right? And that part's perfect.
That part's easy. A lot of people have that.
And you can use repo then to actually, and I haven't done this, apparently you can use it to tag or cross.
That's the problem.
But I haven't done that because
So what would you guys say is the benefit of going multi-repo versus mono-repo?
I would say don't do it unless you have a particular reason. Ours, again, it's you know, no one wants to use our chemistry. We do not want to bring in all 3 million lines of margins. A lot of there'd be some components that the same software is hosted. So the idea is that when you have common area of development, it has to be pulled out somehow. That wouldn't necessarily be another repository. There's no other good analog yet. New, new sub modules, the various different technologies, all more or less look like this is a separate. We're hiding some of it where we don't have to do that with something called didn't really see part of the tree.
Oh, sparse checkout.
Sparse checkout, which almost no one uses knows about. So there's a way of checking out an entire repository and hiding most of the subtrees. And so we're doing that a little bit so we don't have to go quite so fine grained to satisfy. I don't want to see it feeling like some of this is just physicists that don't want to embrace complexity. So we figure someday when they're sort of gotten used to things are just terrible, other terrible things. It really gets better, but they can't complain. Sort
of. Got it.
the thing that prompted us to kind of consider the multi-repository is actually versioning. The issue for us was we had this product that was it's a kernel and then a bunch of libraries. And we had one version for this entire pack and just changed one piece of it. You had to retag the whole thing as a version. And we decided it was better to just have separate versions and one version of the kernel and the version of the pack. Basically, we tag
that part we like a lot. We're really happy with that aspect.
Well, it sounds like the core thing is if you're going to share a subcomponent of your project, that would be a driving factor towards a multi-repo scenario.
Does anyone have one?
The only thing I don't like about our MultiRepo situation is like deployment is not necessarily always straightforward. Like I just want to change this one. I am making a change to, let's say, for example, one of the architectures, there's a web component, there's a background service, and there's a bunch of other things. I'm making changes that only affect the web service, the web application, but I'm deploying the whole thing, right? I can dive in and say, okay, there's a change, but which part of the tree got changed, and then only deploy that part. You know what I mean? Like that's the only thing. So when I hear, like when you have really, really big mono repos, I guess, and what I'm understanding from what everyone else's conversation here is too, is that it just requires more and more tooling or people dedicated to tooling of your CI and CD pipeline. I mean, like, I guess it's not one easy or long solution. I thought the mono repo was the harder way to go, but after hearing all of what you guys are saying, MultiRepo sounds a lot more complicated.
Imagine big argument with like, and want to update version. You want to make sure if you want to have like the number of combinations of things you have.
Yeah.
Not a polynomial or
It's
exponential.
combinatorial.
Yeah,
Eventually.
combinatorial, yeah. And so when you're managing all those versions of all the separate things, then there's some complexity there.
Yeah.
You would have the same thing with MultiRepo, just changing. Still have these versions of all the built functions all held together.
Well, I mean, if you only version the whole thing at once.
Yeah.
In MultiRepo, then presumably with testing, you would only ever test
The whole set.
the whole set,
Yeah.
as opposed to testing like this piece of this version, this piece of this version.
Yeah. I think that's the benefit you get from a mono repo is that you can see your dependencies break right away. And you can update them and fix them all in the same. And so if you're having a commit that goes across multiple modules or whatever, then you can put all that commit in all at the same time. It either all goes in or it doesn't go in.
The default CI just doesn't. Our fastest growing piece of the thing, low level library. It has unit tests, fine, we can build it. It says nothing about whether or not interfaces had to change elsewhere, much less change in science. And so how do we test it? Instead, the CI thing actually checks out a top level process that brings all this in and like hand edits the configuration files that get our branch of the thing and checks to make sure that all still works. But that's a really heavyweight way. And it only works well when it's just one repository. You have two changes in two places. Now, more complicated logic could be that it's not there. And you still have the problem. It's not that once you approve this one, now you have to edit one more time because this configuration file now needs to point to the master object. Okay? Because GitHub always does, this is GitHub always does it. You always get one extra commit. You can't even tag it in advance of anything downstream has to wait until the version pull request is approved so that you have a new SHA code. So that you actually have it consistent down here.
I never thought about that.
We're not, we need to improve upon that, have some strategy. I don't think it's gonna.
Are you guys using, is Noah using Git as well?
They are now, and I'm not touching base with them real frequently, but part of the reason we chose this tool managed internals is because we saw it in their planning document that was what they were doing. And we work very closely with them, so we want to be as compatible.
But you could have had Git sync up with their Git repo.
Which repo?
Well, basically connecting their.
They have their multiple repos also.
Yeah.
So they have a copy of our aerosols code in an entirely different location in their model than we have in our model, with a different build system.
And different version numbers.
Well, they don't, they just took they took a snapshot from us long ago and been updating it.
Yeah.
Probably an SVN for most of that time, and they only recently done to Git. But at any rate, there's no common Git history now. So at the very least, we have to sort of, right now we have to do a lot of these things as, what they call orphan branches with ID because merges are dreadfully dangerous because Git doesn't know about the Once we rectify all this, then their directory is our directory. You know, they might be a version of mine or a version of, but there's no way, the rest of the models aren't the same. It's not like we certainly don't want the rest of their model.
Right.
They don't want the rest of ours. So the only way I know to do it is to do these common factors.
What about packaging though? Like giving them a package instead of like the raw code?
So like the binaries and such.
Yeah, whatever it builds down to the package that you would deliver.
Here's where, you know, Fortran flavors, Fortran vendors, MPI flavors, all that kind of stuff. Everybody's going to use their environment. Some people have trade. Anyway, so that's, in our world, we have to be able to play with lots of.
So
I was
I
gonna
mean,
ask,
that could, what about like, let's say if you have a known set, like, so let's say like with NPM, you had the two like common JS, and a lot of libraries get published out to these multiple things. So like you can consume them in these different formats. So let's say you had like a known set of X, you know, so hey, we can, in our CI pipeline, we'll just kick out this library and these versions and these compile targets or whatever. That, I mean, then you decouple the code from the, like they can update their binaries or whatever when they need to, versus, you know, when you push them
I'm
out.
not sure I understand how would the update the binaries?
So they would, I'm thinking about in, let's say in C# terms, like you'll have assemblies, right? So if I pull in, I publish out to NuGet or whatever my package manager is, here are the different versions. They pull in the versions by referencing their specific version, right? And then when they want to update, they just update to whatever the next version is that we publish.
That include binaries?
Yeah, so
Okay. So
I
that's the
would
thing,
think
can't,
so,
I don't
yeah.
know what compiler,
yeah,
but it's unlikely to be the same as what we're using.
but they wouldn't necessarily need to compile that again, right? So it depends, like I guess depending on what the target is. So if you compile it for like Linux and you compile it for Windows and you compile it for Mac OS, then they can pull that in, or whatever the operating system
And we
is.
compiled it with G-Fortran 8, G-Fortran 9,
Yeah.
Intel 18, Intel 19, Intel 17. Don't forget the minor packages, right? With the various flavors of MPI, which we have, like we might have SGI currently and Intel MPI, Open MPI.
Yeah.
They might want a different version of ESMF, which is a shared thing developed in NCAR, but they're in a different version of that than we are, but it's compatible with the thing we're exporting. So I don't, I mean,
Complicated.
there might be a solution down there, but it's very different than the way we approach these.
Gotcha,
We do is
gotcha.
instead source code and, you know, and then a software stack for the compiler and MPI, all built before.
Okay.
I do not want to see your build script.
Yeah, that looks, that sounds
It's actually- no,
amazingly,
it's scenic. It's very clean.
that sounds amazingly complicated.
All of these libraries.
Well, not our,
Well,
our
the
base
very,
library
very basic, like
compiled.
SCDF and stuff is a little bit different. We use the external stuff for that. But all of the agency developed stuff.
Yeah, so the problem is that for every one of these combinations, I have to make NetCDF, I have to make versions. You know, the only real thing in this area for Fortran is probably SPAC. It's sort of like the MGM, thing, you know, that's again source compiled every time. But the thing is, you can concretize the entire thing.
Someday that's where we.
We hope, I hope to get to the point where at least everything but Geos is there, and then there's no reason why Geos couldn't be put as the last step. Then you can say, I want Geos with this option. They could build from GCC up, so, you know, the entire software stack. Or the other way is Docker. Here's a pre-compiled thing.
That works to the executable. I don't think you can do the Docker
No.
with this library here and that
No,
library.
no, but I mean, it's the other path they need to go. Someone just wants to run it, you know, give it an image.
Wondering, can you specify restrictions on, you know, this works with, you know, this builds under Fortran 7, Fortran 8, something else that's new.
That's where we are.
Yeah.
They do want to do something else, and so they do need. You can't, unfortunately, you can't, I mean, I think the world's probably not as bad. So you have the diet. You know, unlike C, which relies on header files, Fortran produces its contests generated by them. Those are, even when things are C API compatible, which is not always, a lot of the .mod files, oftentimes even, we can't even really link different layers in our own shop between like.
Why are you using Fortran?
Oh, don't go there. I've had this conversation.
No, it's
But
fine.
the retort is, not enough people know about Julia. Why aren't you using Julia?
All right.
I tried doing it. It seems
It's
cool.
really cool. It's a lot. It's fun to play with. Yeah, we're not there yet. But the simple answer, of course, is well. First of all, it's 2 million lines of code. If you have the manpower to write that most quickly, while science advances is great. But it's also a workforce. But there's some hope for those of you on the other side of the spectrum. So, against the wishes of the agencies that are funding, what they call the Joint Center for Satellite Data Simulation, they're funded by NOAA and some of the DoD things and NASA. They're sort of the avant-garde for what's going on in data simulation. They have developed a whole new framework called JEDI, entirely using C++ techniques. And when they came back to the agencies, you're going to use this. They all said, "What? No, we didn't agree to this." And they basically, the agencies have no response. So we all agreed, okay, yeah, in about a year's time, we will now be deploying our model with C++ framework on top, calling Fortran layer below. And at the other end, portability to GPUs, which is another big area of focus, doesn't have a lot of good Fortran support. One Fortran compiler does a decent job on NVIDIA, but theirs really hasn't kept up with the Fortran. So a lot of the advanced object-oriented stuff that I've been putting actually makes the compiler so we can't. So we might be seeing C++ templates eroding from underneath and above, and so we may come back in 10 years and did finally crumble. But in the meantime, there's a lot of nice infrastructure that we have, very hard to replace. Certainly a lot of just raw, ugly, old-fashioned Fortran code that right? We don't know what it does. It's the usual thing with 30. This isn't surprising. The 40-year-old code, like C code, would be just as bad. So,
Yes, anything for your
Yeah.
I had a conversation with one of your customers about Fortran, and he loved the idea that it did big data better than anything else.
Yeah, I would like to know what fraction big data is. I'm gonna
Even
guess.
Fortran-
GMO it is.
we don't do big data with Fortran. We use Python. No, seriously, we do number crunching. So the typical thing for high performance computing is mostly still C++ and Fortran. But the things that Fortran still does very well, even compared to C++, array operations, a lot of nice math intrinsics. What am I also? One nice new thing that you might not be aware of, not that we're using it yet. Fortran is a fully distributed film. Pretty Fortran gives much nicer notation than off-process reference. Second set of these. And that can give comparable performance to AI and fraction of code. It's just, we don't do a lot of that. C++ is jealous of us only on that. I'm on the Fortran committee, so I spend a lot of time.
And for optimizing Fortran, compilers are really good at reading your own code and making optimizers. Usually.
Yeah, I think
C++ is getting closer, but
it's not hard to find cases where C++ does just.
but you have to do things like, make sure that pointers aren't taken as Fortran, you are guaranteed they're not.
Mostly I'm afraid of releasing C++ on a battery. And each language has its own ways to shoot itself. I think C++ arguably has more ways. When we have less sophisticated programmers, it's going to be a long time before we. Even myself, who's a scientist, I think sort of more a software engineer, I can read Java and I can read C++, but not a different hundreds of thousands. I would lose a lot of code. Silly stupid. Take time to learn that stuff.
So we're gonna, again, like I said, this is gonna be a deep topic. Actually, I know. Actually, I want to actually get talking to you about a Fortran talk at some point too, as well.
Yeah.
That would be pretty cool. All right, so we're gonna switch over to topic number 2. I'm gonna start my countdown because I'm always I ramble on and on. So debugging tips and tricks. And this is gonna be a discussion kind of, but I had some slides, so we'll kind of go through them. But hey, that's stupid, then let me know, because I'm here partly to learn other people's tips and tricks. That's my shit. All right, so read the error message. It sounds so silly, right? How many of you get an error message like, I know what the problem is, I'm gonna jump right to the solution, and I don't fully read the error message. I do it all the time.
No,
I've seen people do it. Yeah, we're coming. We're gonna get there. We're gonna get there. We're gonna get there.
Wait,
But
you have a language with error messages?
Yeah.
Fortran goes to a stack trace.
Well, and worse, we get a stack trace from about 5,000 processes or something like that. So you gotta scroll through a long way just to find that first.
yeah, so that both of those, all of what you mentioned is gonna be coming up soon. All right. So, but seriously, read the error message. Like a lot of times, I found people like, hey, they come to me, they're stuck on something, and you read the error message, and it's like, it's telling you what the problem is. I mean, it points out the line and everything. Like it's right there. So read the error message.
You know, at least back in the day, it was probably 15 years ago, we knows error messages were of the order of such and such an error was thrown, and it was just a number, and then you had to go online. Like,
Yeah. So I wanted to do the I keep saying this all the time, and I'll probably stop apologizing for it and just accept this is what I do. I wanted to do the thing where you like bring in the bullets one by one so you guys don't read ahead, but yeah, I didn't have time. So get good at reading the error message. Digest what the error message is actually telling you. Sometimes it throws something and you're looking at it like, no reference exception or whatever the case may be, but it's actually telling you that the thing that it can't find is hanging off the other thing. Like look for the other thing. It's telling you what it is. Like this thing right here doesn't exist. So don't look at like the thing that it says it can't find. Look at the thing that it's hanging off of, right? It's telling you where the problem is, right? Take notice of error codes, right? This was brought up before, right? So more on this when we get to the Google, because there's a whole 2 slides on just Googling, right? That is important. You laugh, but some people don't know how to do it. I might not know how to do it after going through this. So read the stack trace in reverse order, right? Read what's closest to your code backwards, right? And sometimes that's not the order it puts it in. So find the part that's closest to your code and then go backwards from there. Because a lot of times people ignore the stack trace because there's a lot of garbage in there, or what you think is garbage, but it's lower level things. Like this thing tripped up here, and all these other unwind the stack, and it's throwing the error all the way down, right?
XML parsing or
Yeah.
JSON parsing.
Yeah, find the location closest to your code and start there. That's what's going to give you the most context, right? For languages that I try to make this as generic as possible, I could. For languages that you can use anonymous functions and anonymous things, favor actually naming your functions, right? Because then when you get the stack trace, it makes more sense, right? It can actually be helpful to you. If you have anonymous, you're like, well, which one of these is closest to my code? I don't know.
You meant that was a favor name functions over anonymous.
Yes. Yeah. So you don't know me yet. I can't spell. So I tend to write these things late at night or right before the presentation. So yeah, I will fix that.
Just make sure I missed it.
Yeah, I accept pull requests too. So isolate the problem. This is another one, right? Like people I have this problem. They don't know where the problem is actually happening, right? Like get down, isolate the problem. There's a couple of tips you can do that for. So validate your assumptions. Don't just say, I know this can't be the problem, or I know the problem is actually here, right? Based on validate that. Make sure that you really isolate down to where the problem is actually happening. There's a couple of strategies I know about that, and you guys can jump in. So one thing I do is just start removing code so the problem goes away, all right? Comment it out, delete it all together, whatever the case may be. That's what source control is all about, right? You can get it back. Or start from the other side, just start off fresh and try to bring things in until the problem manifests itself again. That helps you to isolate where the problem is actually happening, right? It's coming,
okay.
but I don't think starting there is the best thing to do. And there's a reason. There's not necessarily order, but if you start a debugger, there's a lot of information being thrown at you. Sometimes it's not even true what it's telling you, and we'll talk a little bit about that, right? So, but I think the best tool you can use is your own brain, like your own brain and some of your own experience, right? Start there first, and then work your way outward, right? That's just my opinion. Other people may have different opinions.
Yeah, just to branch off that a little bit, something that helped me, it might seem like a total beginner obvious thing, but I like to just start with one very tiny functional piece at a time. If I have an opportunity to compile it and test it, make sure it works, I do that and then just keep building up.
Yeah,
It
so
builds my confidence.
that's one of the tips that's going to be coming up later on too as well.
Issues easier, like, I just write a couple lines of code, and if that breaks, it's in that couple of lines of code.
Yeah.
Something that interact.
Driven development.
Yeah, so we're going to touch on that a little bit too. So another thing too is read the context, right? So sometimes there's a problem here, but the problem is not really there. It's just manifesting itself there. problem is somewhere above it or somewhere below it. And we'll talk about a little bit of that later on too as well. Once you fix the problem, remove your fix and see if the problem manifests again, right? To make sure that your fix is actually the fix, right? Because sometimes you'll twiddle some bits here, twiddle some bits there, twiddle some bits over here, and all of a sudden it works. Like, this last thing I did was the fix. And technically, no, not really. The other one, make sure your fix is actually the fix. So once you, talk a little bit. All right, so don't program by coincidence, right? Like you just, again, twiddling bits. Like I'm shooting in the dark. Oh, it's working. Therefore, we ship it. But I don't understand why it's working now. I just know it's working. If you program by coincidence, then when something goes wrong, you're going to have a hard time figuring it out, right? Understand what you're doing, why it's doing what it's doing, right? That actually got that tip from the pragmatic programmer. I'm not going to read that to you. I'll send the slides out later. But again, seek to understand not the how and the why, right? Not just it's working. Understand why it's working or why it's not working, that sort of thing. And then you have a much better chance of actually debugging things when things go wrong. So this one. Fine. All right, verify your environment, right? Make sure that you're in the environment you think you're in. I've done this. I'm sitting there messing with code like, this should be working, but I'm changing code in dev and I'm looking at production, right? And it's never gonna work. I don't think it's doing screwing up dev even more and more as I try to get that to work. So add a small change, just make sure it shows up in the environment you think you're gonna be in, right? Make sure you're in the right, I think I said that already. So again, remember I said about the spelling thing earlier? Yeah, make sure you're spelling things correctly, especially if you're not in the type language. I do that all the time. Every time in JavaScript, like, yeah, you just misspelled this thing. Make sure your spelling is correct. Inspect your state, right? So use print statements, and there's the debugger again. We're gonna talk more about the debugger later. But be careful with the debugger. Like let's say you're in Chrome, it tries to help you, try to be more efficient sometimes. And what it will do is like you print something out, and then you try to print something later. It's just using the same reference. So the first one that you printed now gets the second. It shows up what's happening in the second time, because it's by reference and not by value. All right. So just make sure you understand how your debugger works, where it may trip you up. Right. The other thing too with this, I'm not sure if I put it in there. I think I might have, but when you're inspecting things, you're changing how your application is running. All right. So if you have a timing issue and now you're inspecting it, and you open a debugger and it works, and you close the debugger and it breaks. All right, so again, that's why debuggers are great tools. Just don't jump there first. Right? You may spin your wheel on a lot of things just trying to get stuff to work. Yeah. Yeah.
I find where my code is in the code. I don't have a lot of things there that I stick a breakpoint right there, and I go there and I look at all the inputs, I look at all the things in the expression, and if they're not what I expected to see, that's usually.
Yeah.
And then I can go backwards.
Yeah.
But then I get the context of what's happening.
Yeah, I agree. I think it's good.
So a few things. One, maybe I missed it, but I don't think you ever mentioned turn on the, oftentimes the shift version doesn't have that. One of the first things I use is if you go back and rerun it, like a lot.
Oh yeah, yeah.
Maybe you guys all can run. You're getting a lot of context already. You all press performance is another factor.
Yeah, that's
turn on the debugging flag.
Yeah,
That's
because it's a
bad.
timing
I had
issue.
that recently, and it's
We have buggers saying that you add the print statement, it made it work.
Yeah.
that's
So what do? You leave the print statement in and you keep going.
Unfortunately,
That was my solution, but apparently it wasn't.
the one we're going to win with, we have right now a non-reproducible internal compiler. Very hard to put a bug report on.
Yeah.
Anyways, but the comments about this particular side. So I'm glad you mentioned the print statement. When I've given classes before in this direction, I've always, party line, use the debugger, don't use print statements. They're terrible. Really. But I, of course, almost exclusively use print statements. Usually by the time I'm desperate enough to bring up a debugger, I will break the debugger. I don't even know how to use our debugger. I go to other people in my group and say, can you please bring this up and tell me what you see? And just so.
Yeah, print statements are underrated, right? Like it's quite useful. One of the things that happen with print statements that you don't necessarily get in debuggers is sometimes the print statements will help you not run into the timing issue that when you're inspecting So especially if you're doing asynchronous programming, right, where you slowed it down here just enough time for the asynchronous call to come in when it's supposed to come in, and now the problem does not manifest itself. But a print statement would have been like, and it's there, you'll see it, right? But again, make sure when you print something out, that it's not printing by value, but it's printing by value. It's printing it as it was right there. It's not printing and showing a reference to the thing, right? We'll talk a little bit more about value and about reference later.
Does anybody use loggers?
I was gonna say.
Yeah. Yeah, logger is printing print statements. I lump those together, right?
But the thing is, like, what's nice about it is, like, you put in stuff as a demo collaboration, not, like, if you accidentally left in.
So now let's talk about searching, right? So one does not simply search for cats, right? All right, so learn how to Google, or AKA search. Everyone uses Google in terms of search, right? So the way I usually do it, start with the error message, right? You can literally sometimes just copy and paste the error message in, and that's going to get you pretty far, right? If you have error codes, throw those in too, right? Those are usually very specific, and you can usually get back very specific answers. Keyword search, right? So search for the meaning of what you're trying to do. Don't just randomly throw in text into your search, because it's just going to confuse things, right? Google's pretty good at pulling out things that aren't useful, but the more you can help it, the better, right? I'll give you an example of this. Someone asked me to help one of the developers on our team. He's no longer here, so I can talk about it because I don't have to worry about embarrassing him. He had a process that was running, and when he started off, it was a couple hours, then it was a couple more hours, and it was like days before it finished. It was an exponential problem, right? He had an exponential algorithm. The more data he got in, the longer it took to run, right? So I looked at it, and said, oh, this is an exponential problem. I mentioned that to him, and he didn't understand what I meant. I said, I'm going to go to the bathroom, Google it, and when I come back, let me see what you found. So instead of Googling how to solve his problem, he Googled exponential algorithms. So did he find a solution? Did he get anything from that? Not necessarily. So Google what you're looking for, right? Try to understand how to form your Google phrases or whatever. So use terms that will likely come up in blog titles, or like a Stack Overflow question, right? Or something along that nature. Like Google the way you would think the solution will be presented, not necessarily the exact phrase of the problem that you're having, because you're trying to find the solution, not trying to find the problem, right? Does that make sense? Does that make sense anymore?
Yeah, but most of the posts will be, I got this error. Here's what I have for code. Where did I go wrong?
Yeah, so you'll find those when you search for the error message. But if you didn't find it when you search for the error message, you need to understand what the problem is so that you can put that into the search term, right? This is where, again, like I say, there's an order to it. Not everything is in order, but search for the error message right away. Search for the error code right away. That gets you far most times. But if it's a complicated bug, then you got to search for the problem, and then that will help you find the solution.
I was gonna say, go after either the library that you're using that blew up. Find out where that goes. Usually those will get connected.
That's coming up.
Oh.
All right. So when you get the search results back, like I don't know about you can't read every single one of them. Not all of the search results are equal, right? So there's a little snippet that Google gives you. Skim through the snippets before you even dive into the page, right? Because I can tell you right away a lot of times whether it's worth clicking on that link or not, right? A lot of times this is my own little tip. Actually, not my tip, Layton's tip that I picked up on. Open open the links in a different tab. That way it gives you context. Like, this is not the one I want, just close the tab and you're back. You have your search already open, right? Helps with a little speed up thing. So these other one, use the tool like in Google. Let me pull up Google real quick. Let's see. I go to Google. So I found this a couple years ago. All right, so this thing here. Do you guys use this?
No.
All right, so this thing right here is a lifesaver, right? So you go to tools and you say, I have a problem and I'm running, let's say, the latest version of .NET Core. chances are my answer is not going to be 3 years ago, right? It's going to be within the last year. So limit your search to that time frame, right? If I'm working on something that's really, really old, let's say I have some, I don't know, I don't want to step on anyone things. I might step on someone. I have something old, or let's say I'm using SQL Server 2008, right? Okay, so I was trying to think, so, yeah. Then you might want to limit your search to some older things because you don't want to get the 2016 version fixed. And it's like, well, that doesn't help me. And it's clouding up my searches, right? So this thing I found to be really, really useful, especially when you're working on something that's newer, right? Limit your search to the time frame in which you want to kind of find it.
And a little branch off of this.
Yeah.
You guys didn't know Google has its own syntax for this one?
It's coming up.
So,
Jumping
I'm
ahead.
sorry if I spoiled.
No, you're good. No, go ahead. Go ahead.
Just- Since you're talking about filtering and sorting and stuff, the syntax that you use in your search can really help you pick
Yeah.
out the meat of what you want, or then that'll probably come with just.
Yeah. So there is like that search box is like a little query language area that you can put things into. Let's say I wanted to limit my search to just Stack Overflow. Then you put in site stackoverflow.com. Here's my question, right? And it'll only give you results from Stack Overflow, right? And there's a whole bunch of other things like that. That's why I said I Google a little bit, but there's some people that are like expert Googlers. You know what I mean? Like they can find anything. And it's based on how well you know how to use that tool, right? And so those are just two tips, the time-based one and the domain-based one. With those two, I'm pretty proficient. But there's more that you can do in there as well.
You do minus and plus.
No, I don't. I didn't know about that.
Minus will actually say that term.
Don't include that.
So that term,
Uh-huh.
and plus will guarantee that term.
See, this is why I like doing this,
I
right?
think quotes along a phrase will guarantee.
Yes.
Yeah, so in that tools thing too, you can say, give me the verbatim as well, right? So you can say, because Google will try to take your term and do that search thing with it, where we talked about last time, where it's like, you meant that this has the same meaning as these other things, right? But if you say in that tools thing, say, give it to me verbatim, it's going to only give you that phrase verbatim, right? Yeah. All right.
Go to Google and just type in Google search syntax. You'll find a whole list of examples. Awesome.
Use Google to search Google.
Google.com.
So I remember, side note, I got like 10 minutes. So when people used to ask me stuff all the time, they know I was good at searching things, and you send them back to the little thing and let me Google that for you. You know what I mean? Like, it's like types it in Google and sends it to them. People tend to get mad with that one though. All right, so not all resources are created equal. Know what resources are more likely to have the answers you're looking for, right? So if, for example, in the web world, MDM versus W3C, right? They're not equal. Like they have some of the same content, but they're not equal. So if you see two of these things in your search results, favor the one that you know is going to have the better results for you, right? Stack Overflow, popular blogs and bloggers on that particular topic. If you get to know some of those people, then it's easier to find answers via those people, that resource. Twitter, even like our Teams thing now, right? So if we have very specific NASA type things, chances are you're gonna better off finding that within the community, right? Than somewhere out on the open web. I think this was mentioned before, but look, if you're using a library, search GitHub issues for that particular repo. Chances are you might find the answer that you're looking for in there. The other one too is just diving into the code. Sometimes that helps as well.
So one thing I've found recently was that, if you figure that you have found something, actually you're trying to decide like where you should go, actually you're probably better off repo than repo, because for working on the repo, they're going to see it. It sort of makes sense to say that, right?
Yeah.
Particularly for things that are less common. Creating an issue to get
and that depends on the project. Because some people will be snippy and say, this is a question, not an issue. And they'll just close it. But in general, I think that's why I say search to GitHub issues, because other people would have asked might have asked the same question in issues, and they'll close it, but they'll point to the Stack Overflow question that you end up finding the answer. Right. So the other one too is like some of these environments are not open, so Google can't crawl them. So make sure you're doing if it's valid for you, like let's say Twitter. If you think that you might find the answer on Twitter, then you need to go to Twitter and actually search there, because your Google search is not going to find it because it's a closed environment, right? So just keep that in mind too as well.
It's a 144 character response.
Twitter is very valuable. Trust
Yeah,
me.
no, I've
Oh my
always
God.
just-
Oh my. Oh no.
People, like, yeah, you could see
Yeah.
it's an admin issue. There's-
Yeah. And you mention the people that do stuff in that community, they respond.
There's some research on NPR today about the value place for their online. This is European, but it's like on average, like $17,000 is what people browser. The emails a little bit less, and they went down to the very thing. Twitter was zero.
Wow. I don't know, man. So yeah, Twitter's been very valuable for me for finding issues. And
Okay,
Getting
can you
to-
send me?
yeah,
I've
we
never
can talk that
Twittered.
more online. So all right, clean code. Why are we talking about clean code and debugging? Because they go hand in hand, right? Who cares about clean code? I thought that was funny. I didn't. Yeah. All right, so write cleaner code. It sounds like yeah, whatever, right? But seriously, like favor pure functions. Pure functions are so much easier to debug than functions that just reach out to the world and grab stuff. You know what I mean? Because if the input goes in, the exact same output should come out. If it went in and it was broken, it went in and it was fine, and came out as broken, chances are the problem is in there. If your function grabs all things from the context and brings it in, then you don't know what actually is the problem. You know what I mean? Or like I say, you don't know. You can't rule that function out as being the problem, right? Does that make sense? Yeah, I said it horribly. All right.
I have a question for you.
Mhm.
How many people? I came from a C, COBOL, Java. I write Python and Perl. How many write in that kind of style?
You know why?
Did you see Marston's talk or his link to a talk of if you're gonna write Python, write it Pythonic versus non-Pythonic?
So I'm writing it the way that gives me the least amount of headache when
But
when I
it's
have to go
not
and
cleaner. It's not cleaner, and it's
It
not.
can be. So this is gonna be a side
Reasonable
thing.
people can disagree on what.
Yeah.
there is and
So the reason I say, because you can't write everything pure, right? But if you can write your thing where it's a series of pipes where your data is going from here through here, transform through here through transform, and you can put debug statements in between there, and you know that it's not doing anything. If it's fine here and it's broken here, the problem is in here, and I don't have to worry about any other context. So we'll talk more afterwards. But the other parts of this is favor simple code versus succinct code. A lot of us try to.
Comments.
I do not agree with the comments thing, and I'm
No.
partly wrong on that.
I disagree too.
I'm partly wrong on that. I've come to realize that as I've onboarded more people to my code base. So things that my problem with code with comments is that a lot of my career has been working with legacy code that other people have written. This is the reason why I favor pure functions. Part of the reason why I favor pure functions because it's a lot easier to debug other people's code. But there's other reason why I say the comments thing because I've had comments lie to me. Right? Because they were written and they were maybe true at one point. They are not true now. Right? So I'm like, is the comment wrong or is the code wrong? I don't know.
I think it's important to distinguish two kinds of comments. So a block of comments in the procedure that says what this procedure is about, why it exists, is likely to survive the test of time and not mislead. Comment next to a line or before a line saying what this next line, how this next line does, is always inferior to what the language is saying. Improve how you use the language is almost always better. Now there's something obscure that a comment
Yeah.
is going down. That should be not the default.
So the comments I prefer to see in code is the why, right? Like I did this because blah blah blah. This is ugly code. You're gonna want to try to refactor it. Don't do it. Right? This is here for a reason, right? The comment that says this is setting the variable to X, well, then the next line says I set X equals blah, right? It's just junk, right? Because later on you change the Y, and now I'm like, what the hell are you talking about? I don't know, right? So if you're gonna put comments in code, especially nowadays, right? Like if you look at it and you say, with Visual Studio Code and Git Lens and that sort of thing, it gives you the commit message right beside the line, right? Do I need the comment in the code, right? I'm not saying it shouldn't never comment, because that's my pendulum has swung way too far to the, like, your code should just read like a book. You don't need comments. I realize that's not true, but be careful about comments. All right, we're running out of
But
time.
also you have to name those functions correctly.
Yeah,
It makes sense.
spend some time
Not
naming your
just like
functions.
Function Y.
We're Fortran, our variables tend to only be 2 or 3 characters long. So no, there's a lot to, but no, there's a lot to be said about it. If you take advantage of, make this great for the reader, then you can avoid some.
Yeah. So in general speaking, the last statement you just made, I'm sorry to cut you off. Write your code not for right now. Write your code for you reading your code later. You spend way more, if you actually take it on a timer, spend way more time reading code than you actually spend writing it. So optimize for reading code. And that's where the whole succinct versus simple, like, I can make this a one-liner. Don't. It's not necessary. The compiler's going to do that for you. Like, who are you trying to, don't do it. It's not needed. Trust me.
So one of the, I have to run, but one of the comment I make, pure function, that two important aspects to that. If it is a pure function, then it's going to be a lot easier to create a root feature.
Yeah.
Hand off to somebody else. We have to probably deal with broken compilers more often. It's nice to be able to do that very nicely. But it's also the right thing to do, because the other thing you should be doing at some point, there's writing a unit test, so the next person doesn't have to debug this.
There you go. It's a lot easier to write unit tests on pure functions. A lot easier. Right. All right. So make small changes. Robert mentioned that earlier, so we won't rehash it. This was funny. I thought this was funny. All right. Study common errors. Right. This can help so much. Once you know the pattern of errors, like I mentioned, that null exception. I look at null exceptions, I can see past the matrix and I see the problem, you know what I mean? Because I've studied that error enough to say, okay, this looks like a null exception error. I'm going to look not for the thing that it's telling me is missing, but for the thing that it's hanging off of, right? Race conditions also kind of manifest themselves in some of the same ways over and over, right? This is often due to asynchronous programming or multi-threading, that sort of thing. Network problems also sometimes manifest in the same way as well. Data problems, this is one we had, like, we're using React and GraphQL, and it'll throw errors, this particular library. If you didn't have a data type of, like an example of that data type, it didn't pull it in. So GraphQL is throwing an error saying, hey, something's wrong with your query. But in actuality, you just don't have the right data, right? So some of those things are context specific, but if you see an error multiple times, store it away in your memory somewhere, right? Like, this is not the error itself, but the pattern. Then you can recognize the pattern later on. It'll be a lot easier for you. Same thing with configuration problems as well. All right, so understand how your code is compiled or parsed. All right, so a couple examples of this. In JavaScript, functions are hoisted to the top. All right, so if you put a function at the bottom and you expect the variable to be there because, you know, it's below the variable length, right? But you hoist it to the top, then it's running out of scope, and now it's throwing undefined errors or unknown behavior, right? Because you didn't understand how the file is actually parsed. Same thing with another example is this is .NET codes. When you build your assembly, it builds it like dependency order. So if you have something wrong in your lower level dependency, you're gonna get hundreds of errors from the higher level dependency that are totally irrelevant, right? You can try fixing them, but they're not actually broken, right? You have to go and see what the dependency was that broke that caused all the other errors to get spit out. So know how your code is compiled or how it's parsed. Not in deep detail, but know a little bit about it. That helps to debug things a little bit as well. All right, be humble. All right, don't be afraid to ask for help. A lot of us will sit there and bang our head against the wall for like days before we just get up and just like walk over and say, hey, I'm stuck. I need some help, right? It is a big part of debugging, in my opinion. I'm out of time too. All right, ask for help, but how do you ask for help? This is key. So that's exactly how you don't ask for help. So I've done this, and I've had this done to me before. It's like, the thing is broken. Okay. What have you tried? Help me understand the problem. Like, have those things already canned. Like, here's the problem. Here's what I'm expecting, right? Here's what's happening. Here's what I've already tried. So we don't rehash all the things that you've already done, right? If you do those things, it's a lot easier to get help, right? Yeah, you still have the problem.
No, 90% of the time you figure out the problem.
There you go. That's the next one. Rubber duck. If you organize your thoughts in this way to get help, you will often find your problem, right? And that's called rubber duck debugging. Like, try to explain it to someone else in a way that they will get it without any context, and you often find the loopholes in your thought process, right? Because you remember, I think I mentioned it earlier, but you have to check your assumptions. We have all of us start with assumptions. You have to make sure you verify your assumptions, because a lot of times when you go to explain to someone else, they will then verify your assumption, or you try to explain it to someone else. You're having to verify your assumptions, and then you find the problem, right? Pair programming is another one too as well. I think it's very, very useful. For this, we can't dive into it too much, but I think we're going to do another talk on this later. We did one. Leighton did one before we left on VS Live Share. Excellent tool. That plus a video conferencing tool, I think, is awesome for helping do this. I think that might be the last slide. There was a couple other things, but I am out of time.
I just wanted to say with the rubber ducking, actually, as far as the tool is email. Just open a blank email. Don't put don't enter anybody's name there, and just start typing out.
Mm-hmm.
And that I've had several. Was going to send it to somebody for help and figure out the problem.
Yeah.
So your draft folder is immensely full.
Usually I end up copying what I wrote, pasting it in the document somewhere from a future reference, and delete the drafts. Drafts like that.
So, and does anyone else have any tips or tricks you want to share with the group, and especially online too as well?
I have to leave it. One thing that you didn't bring up, and I can't. So I have this. When I'm working with a language where I can have like a REPL while I'm working, there are a lot of times where I use that for expression. So like if I have some situation where it's fairly complicated setup, and then I get to a point where I'm like, I'm not sure what I'm going to do next. A lot of times I just create my unit test that does that setup, go through the function until I get to a point where I'm not sure what's going to happen next, put a breakpoint, and once I'm there, because then I have all the context and everything I need, then I just start in the debugger until I get the code right. Like especially like array indexing, like if you've got multi-dimensional arrays and moving things around, it can be very tricky. Off by one errors happen all the time. So that is something I can play a lot.
Yeah, I agree. I kind of lumped a lot of that under inspector state, right? Where he's like, let me figure out what the state of the world is, but actually spelling it out, saying use your REPL, like get to that breakpoint and actually say, well, now the world stopped.
Right.
And I can walk around the world and see what's happening, where things are. Like, wait a minute, that variable is supposed to be set and it's undefined.
Right, exactly.
Right, that sort of thing. I think that's immensely useful.
But this is what I mean. It's like this is for actually code where there's no bug yet. I haven't written anything yet. I don't know what to write. So sometimes if I don't know what to write, I will actually debug to that point and then at the REPL try several things until I get what works.
Interesting.
You know,
Yeah.
because sometimes just to get in, the documentation of political library, it says it returns X. X, what does X actually look like?
Yeah.
So sometimes getting to that point to actually see exactly what it.
I like
that
that.
a lot too in JavaScript. You
Yeah.
can just pull up the console, right, and you just start
Going for it. Yeah.
Yeah.
what stuff does, and you have the values and you can write your code, but it's just in the console, not in your actual code piece.
Right. And then when you're done, carefully grab the stuff from the console and you're like, okay.
Yeah, I like that idea.
It should be this.
I want to go back to that our comments discussion.
Uh-huh.
I went to a very interesting talk at the last Django Con. It was all this woman did a survey of different programmers and asked them how they use their comments and kinds, and she had some very interesting findings about the different type of programmers, like experienced versus new, and how they use their comments, and basically different programmers use comments.
So did she come up with any definitive, like, this type of programmer does this for this particular reason?
I think I couldn't spell it out for you now. I have to watch the thing again, but
I think one thing I could say from my experience at least is object-oriented languages tend to have less comments because the object-oriented nature of it, you can follow what extends what, what's the child of what, parent of what. But if you're in like a scripting language, it can get real messy. So I've seen a lot more comments there.
Yeah, I'm hopefully pendulum is swinging more towards the middle. I've had the alert, like when I first got here, it was hundreds of lines of code, hundreds of thousands of lines of code and comments that were just like, I did this on a Thursday. Not useful, not useful. It'd be like, this person's name, I changed this on Thursday, and then like right below, there's another comment saying, I am another person, I changed it on Friday. That's not useful, right? Or comments that lie, or comments that tell me exactly the thing that's right below it. And now I got to read through the comments to see, like one thing I did find, and if you're using Visual Studio Code, there's a tool called Better Comments. You can set how you want to see the comments. So like to-dos are in a certain color. Regular comments I make almost invisible. So they're like out if I need them, I can see them, but now I can just see the code, right? And if I want to bring the comments in, I can bring the comments forward, change that color or whatever. But that helped me a lot for code bases that are like littered with comments. You know what I mean?
I guess, I work very little.
Oh, that's your wonderful life.
Yeah,
Wonderful life.
It's kind of fabulous.
Yeah.
So we're in the process of rewriting entirely. We've had money, like, completely different code base, completely different tool. I hate to have to work with.
Yeah. Some of the code I work with is I think it's like 20 plus years old.
Well, that's why it's so commented with things like that. I think
This
source control.
yeah, there's no source control, like that sort of thing.
When I
It's
started, it was mostly, I mean, now it's better even with this version, but.
mhm. Yeah.
And the person who wrote it was still there, and it was very sensitive because when he changed, there's no comments, so you just try to fix it, and then they get so upset that you change their code.
Yeah. So that's another whole topic on like you don't own the code, you know what I mean? Like it's code ownership, that sort of thing, where people are like, don't touch my code. It was perfect. Just like it was. It was crashing, but it's crashing just the way I designed it.
Hey guys, we have extra pizza.
Oh, yeah.
Anybody
All
hungry?
All right, so I think all right, we're gonna sign off here. Any comments before we go? I think there might have been some comments here that weren't fun.
We
All right, so we're gonna sign off. Thanks, everybody.
So it used to be a couple of